All right, guys, there I am right there. All right, we're going to take a look at angles of elevation and depression today. And really, it comes down to understanding how we look at things. All right, so let me paint you a little picture here. All right, so here is a guy. Let's call him Troy. All right, there's Troy. And normally, all right, and Troy is you. Okay, you are Troy. Normally, our gaze, our eyes are looking straight out. Right? This is normal. All right. If you were normally looking down or you're normally looking up, you are different. Okay. We have a fixed gaze straight ahead. That would be essentially a 0-degree angle. Right. We are, our eyes. They're not looking up. They're not looking down. They're looking straight ahead. Here's my arm saying, "Hey, look, I'm looking straight ahead right now." All right. But if we have to look up or look down, then we no longer have eyes looking straight out at a 0-degree angle. So, for instance, if we put a bird right here's, that's the worst bird. Here we go now. Nope. Where's my back arrow? Here's my back arrow. There we go. Caw! There's a bird. There's a bird right there. So if Troy looks up to this bird, notice that there is an angle, and his gaze has elevated, huh? His eyes, and see my little pointer here, his eyes are looking up to look at the bird. And so we would call this right here, this is an angle of elevation. Okay, right here, this is an angle and think about what we've been talking about recently with trigonometry. Of course, we could make a right triangle out of this. There's a little right angle. Okay, there is a distance, a ground distance from Troy to the bird. There is a distance from Troy's eye to the bird up here. I'll just label that Z. Okay, that is the distance from Troy's eye to the bird. And then there is a height, some height right here, that is the height from Troy's eye to the bird. So there's a right triangle right here, and we have an angle of elevation. Okay, hopefully that's kind of painting a picture for us. Now I'll keep this picture. Is this what I want? Yeah, let's duplicate that. And let's delete some stuff. Deleting stuff. Okay, so we're pretty much back to normal here. All right. The bird, we're not talking about a bird anymore. Troy, typically looking straight ahead. Of course, Troy's looking straight ahead. But then there's something on the ground. There is there's a shoe. All right. And Troy had to look at those. All right, he had to look at those shoes because, well, they were so beautiful, I guess. Beautiful shoes. He's like, oh, look at those, and so he does. He looks at those shoes. Now, notice and this is this right here, and look at me right now. All right, this is where a lot a lot of students screw up. You might screw up too unless you pay close attention to this. All right? Because setting this triangle up is life in these kind of problems. All right? It's instant no chance of getting the problem wrong. Or right. Instant no chance of getting the problem right unless you can do this right here. So, right here is the change in angle. Notice from going straight out to where he then looked. Right here is the change. Right here is what we would call the angle of depression. It's right there. So notice now, if I do form a triangle with Troy and the shoes, the angle of depression is outside of that triangle. And students want to incorrectly put that angle right here. They want to put it on the inside of the triangle right here. Let's zoom in. Are these two angles guaranteed to be the same? No, they are not guaranteed to be the same. And you know that, all right? But we have to understand what an angle of depression is. It is the change from looking straight out like normal. It is the change that we had to get to look at what we wanted to look at. We had to look down at some angle to look at those shoes. But there is a silver lining to this, all right? There is an easy, helpful way to get through this. Notice that this straight gaze right here is parallel to the ground. These are parallel lines, so this right here and this right here are congruent. These angles are congruent. Why are they congruent? Because they are alternate interior angles. So, the angle of depression of Troy looking down at those shoes is the angle of elevation of the shoes looking up at Troy. If these shoes was a turtle, because we love turtles. Okay, if this, which does have eyes, the angle at which Troy has to look down at to look at the turtle is the same angle the turtle has to look up at to look at Troy. One's angle of depression is the same as the other's angle of elevation. And this right here, now we have an angle on the inside of our triangle, and we can use, the measurement of the length of the ground between Troy and the turtle. We can use the height of Troy right there, and we could even use the distance from Troy's eyeball to the turtle's eyeball if we needed that distance also. Of course, this is a right triangle because it is going straight up from the ground. These two demonstrations right here, super helpful. Right here is some more information. Angle of elevation, angle of depression. I'm not going to read through this word for word, but if you want to use those notes right there, you can always stop this video and check it out. Yep. Pretty much what I said, but with different words. Maybe better grammar. That's for sure. All right, let's take a look at a word problem. James is a pilot. But we've been working with Troy. Let's just promote Troy from regular human in the last problems to pilot. Let's keep this simple. He's in an altitude of 35,000 feet. At an angle of depression of 6 degrees, he sees a landing strip. What is the horizontal distance of the landing strip, what is the direct distance from the plane to the landing strip? All right, so the first thing that I recommend doing is drawing a picture. Draw a nice picture. So I'm going to give myself a plane. Troy was definitely... that was a beautiful plane. Thank you. Troy's in that plane. Altitude of 35. Altitude is... It's going to be the height of this triangle, right? Altitude, when you talk about like how high a plane is, altitude of a mountain, we're talking about the height from the ground. Mountain would be from sea level. So hey, altitude 35,000 feet. Way out here in the distance is a landing strip. Maybe there's like a big tower out there to help him land. I don't know. It's not the... I've drawn much better landing strips in my day. But it's okay. All right, so... Well, Troy would be looking straight, of course. I mean, I've never piloted a plane, but a typical gaze is straight ahead. That's what we know. And his angle of depression was 6 degrees, so that is right here. He looked down at 6 degrees in order to see the landing strip. But we know the angle of depression for James is the same thing as the angle of elevation of what he's looking at. So that 6 degrees also applies to this angle that is the alternate interior angle with our parallel lines, everything we talked about in the last example. So we want to know the horizontal distance to the landing strip. Well, horizontal, we know what horizontal is. It would be this right here. Horizontal distance, I'm labeling it as X, plane to landing strip. What is the direct distance? Well, I'll label that Y, directly from the plane to the landing strip. Not talking about horizontal, we're not talking about vertical like the altitude. Direct distance would be Y. So now we can set these up with our trig. I'll just put myself right here in the middle. Hey. Okay. So if we want to find X, our horizontal distance, well, we have our angle. We have our opposite side. We want to find our adjacent side. That's going to be tangent. So tangent of 6 degrees equals opposite over adjacent. And since our variable's down low, we're going to switch O. X equals 35,000 divided by tangent of 6. And if I type that in my calculator, make sure my calculator's in degrees, it is 35,000 divided by tangent 6. All right, I got 333,002.756 feet. That's a lot. But think about that little 6 degree angle. 35,000 is going to be the shortest side of this triangle by a lot. I mean, this would be what? An 84 degree angle? So this side's going to be monstrous compared to that shortest side. Let's also find y. Well, y is the hypotenuse, so we have the opposite. We want to find the hypotenuse. Well, we're going to use sine. Sine of 6 is equal to the opposite over the hypotenuse. Variable's down low, so we are going to switch O. And this is 334,837.028 feet. All right, so we talked about the difference between angle of elevation, angle of depression, although they're pretty much the same thing. You just have to think about looking straight out, just like normal, straight from your eyes. And the angle of elevation depression is the change in that gaze. Draw yourself a picture, set up using your trig ratios. The setup at the end should be the easy part because all we're doing is using a triangle, but we have to draw that triangle correctly. All right, stay sweet.